For our third problem for sectors and segment areas for circles. This mostly a sector problem for a circle. Let's try this problem. So Marianne, who works at the attic floor at their building, observed that the metal braces supporting the roof forms a triangle whose sides measure 6 feet, okay, 6 feet, and then 4 feet. To the nearest inch, we need to find the radius. We need to find the radius of the circle. Okay, the circle of the largest circular warm air duct that can be bored through the opening of the braces on the roof for this problem. Okay, so since we have here, okay, an equal side measurements 6, 6, and 4, we can use the Heron's formula to solve for the area of our given circle for this one and to find the radius. So solving for the Heron's formula, we're going to use this formula S times S minus A times S minus B times S minus C. And also we're going to be using another formula. We can find the area of a given triangle inscribed in a circle for this one. Okay, so that's gonna be 1/2 the radius times the perimeter of the given triangle. Okay, so that's gonna be the area of the triangle itself. So first we need to find the area of the triangle using Heron's formula. And what's gonna be the value of S? So that's gonna be A plus B plus C divided by 2. And that should give us 6 plus 6 plus 4 divided by 2. And what's 6 plus 6 plus 4? So that's 12 plus 6, 12 plus 4, so that should give us 16 divided by 2. So therefore, the semi-perimeter is just equal to 8. Okay, and to get the area of the triangle, we just substitute our values. So this is going to be 8 times 8 minus 6 times 8 minus 6 times 8 minus 4. And therefore, this should give us 8 times 2 times 2 times 4. And therefore, this should give us 16. Okay, 16 times 2 is 32. And what's 32 times 4? So that's equal to 128. Okay, and what's the square root of 128? So if we're gonna factor that out, so that should give us 64. 64 times 2. And since 64 is a perfect square, it's gonna go out, okay, of the square root. Therefore, the answer for this one is gonna be 8 square root of 2. Since the area of the entire triangle is equal to 8 square root of 2, we can equate that using our formula for finding the area of a triangle with a circle inside of it. Okay, so that's going to be 8 square root of 2 is equal to 1/2 r, or the radius, times the perimeter of the triangle, which is just 6 plus 6 plus 4, which is equal to 12 plus 4, which is equal to 16. Okay, so this is gonna give us 8 square root of 2 is equal to, okay, 16 over 2r. And this should just give us 8 square root of 2 is equal to 8r. And therefore, okay, the radius is just gonna be 8 square root of 2 all over 8. And the radius is just gonna be equal to the square root of 2. Okay, so what are we trying to solve? We need to find the radius, which we have found. It's equal to the square root of 2. Okay, the radius of the largest circular warm air duct that can be bored through the opening formed by the braces. Okay, so therefore this is gonna be the answer. So R is just gonna be equal to the square root of 2 for this one. Or if we're going to use our calculator, so that's gonna be 1.41 foot. Okay, so that's the maximum radius of the of the circle that can be inserted through the warm air duct for this problem. And that's how we solved it.